We will now continue with our lesson on solving systems of equations, this time using the process of elimination. So when we look at this first problem, 3x minus y equal to negative 2 and x minus y equal to negative 4, our first step is going to be to set up the equation so one term is opposite of the matching term in the other equation. And I know that sounds kind of silly sounding, but what I'm looking at here is that I have a minus y and a minus y. I also have a 3x and an x. The minus y and the minus y are what trigger to me to be the easiest ones to work with. But I see that it's negative. And so what I'm going to do is I'm going to actually take this one and multiply by a negative 1. And by doing that, I end up with an equation that is negative x plus y equal to 4. And now I can take this equation and this equation and I can add them together. So I'm going to mark that I'm going to add them together. Negative 2 plus 4 is 2. Negative y plus y, those cancel out, and 3x minus x equals 2x. So then I've got, well, now that I've gotten that, I'm going to go back to my summary, and that's going to be to add the equations together to eliminate that one term. So then step 3 is going to be to solve for the variable, and we'll get into step by solving for the variable, which we take 2x equals 2. We're going to divide by 2 to get x equals 1. So now we look at that second step, and we're going to substitute into one of the equations to solve for the other variable. Which equation we choose does not really matter, being that we've used them both together already. We're going to end up checking the other one anyway. So I'm going to go ahead and put that into my first equation. And so with that I get 3x, or 3 times 1 minus y equal to negative 2. 3 times 1 is 3 minus y equal to negative 2. I'm going to subtract 3 from both sides, giving me negative y is equal to negative 2 minus 3, which is negative 5. Divide by negative 1 to give me y equals 5. So my solution should be 1, 5. So if I go back and check that in the other equation, if I take 1 minus 5, I do get negative 4. So I know that it is correct. And finishing up that last step is to check your solutions. Moving on to the next example here, I have negative x plus 7y equal to 8 and x minus y equal to 4. When I look at these two, I see that I have a negative x and an x, and they're opposite each other already, so I don't need to do anything to either equation. Negative x plus x, those cancel out. 7y plus negative y, or 7y minus y, give me 6y. And 8 plus 4 gives me 12. So 6y equal to 12, divide by 6, I get y is equal to 2. Put that back into one of the equations, and I'm going to choose my second equation this time, and I get x minus y, which is 2, equal to 4. I go ahead and add 2 to both sides. I get x equals 6. So my ordered pair solution should be 6, 2. If I check that, I know that 6 minus 2 equals 4. Negative 6 plus 7 times 2, negative 6 plus 14 does in fact equal 8. So I know that my solution is correct.